Hey guys, so I'm doing this video today on this metal detector kit from ICStation. They sent it to me to put together and review. So this is the put together video, and then hopefully I'm going to do a follow-up video soon that will have sort of just like a look at how this works, and I'm going to probably look at some of the waveforms on the oscilloscope and see how they change when you put metal near it. But yeah, it's a pretty cool product, and it does work. I'll go ahead and put a link to the time in the description where I show the finished product if you don't really want to watch me assembling it. I included that though just because I know some people like to watch soldering. It's sort of relaxing or something. So yeah, go ahead and stick around for that or skip to the ending part, whatever you like. Cool, enjoy. Hey guys, so today I have this metal detector sort of DIY project from ICStation. They generously gave it to me to do a review and, well, just to build it on YouTube here for you guys. So go ahead and check them out. I'll be putting a link in the description to this item. So here it is. Go ahead and focus. Okay, so yeah, I got the circuit board here, and we have a big coil here, which is going to be for doing some kind of capacitive metal detecting. This is actually something that's pretty cool to me. And we have some resistors, we have some terminals, we have a little buzzer. That's going to be for letting us know when we have a match on the metal detector. A little potentiometer, I'm guessing that's going to be for adjusting, probably for adjusting the sensitivity. So yeah, and besides that, I don't have any instructions or anything for how to do this, so we're just going to have to match things up to what's on here. Let me go ahead and get my multimeter out. It's kind of under a bunch of stuff. So I guess it's always good to start with the lower profile components, which in this case is going to be our resistors. Make sure you can see the meter. So let's just start getting things going here. I'll get the soldering iron warmed up. And yeah, I'm not a fan of trying to read the resistor values, so multimeter it is. So we have a 2K to start with. Yeah, so anyway, I know it's been a while since I've uploaded a video. Basically, I'm in university right now doing electrical engineering stuff, and it's really busy. So I'm looking for a spot for a 2K. Oh, it's kind of interesting how so these are capacitors. We have a 200K there. I'll go ahead and get the camera closer for you guys and then lock the focus. How about that? That way you can see the soldering happen. I got a better camera mount. It's sort of a microphone stand, so I'm using that now to hold my camera. So hopefully when I move my desk, it doesn't shake the whole camera. Before I was using like a clamp lamp mount that just didn't work very well. This is a stand that's on the floor, so its movement is separate from that of the desk. Okay, so we're looking for a 2K. 2K right there. Put that in. Yeah, getting the focus on stuff like this is kind of hard, so sorry if the video is not always in focus. Okay, 2K. Let's see, what's this? 500 ohm. Take these little tabs off. So yeah, I'm a sophomore in an engineering program. We're really busy right now. Had several like 2 a.m. nights, but it's all really fun for me and I enjoy it. Oh, maybe this is actually a 470 ohm. So that's going to go here in the spot that says 470.
Cool. How can I fix the focus for you? Let's get this in here. And then focus on that maybe. I know how it is trying to watch videos that are not in focus. It's really annoying. So try to fix that for you guys. Okay, looks like we have one more resistor here. $200 ohm. I guess I could have inferred that based on the fact that there's only one more resistor spot, and it is a 200 ohm. Okay, get those in there. Now let's flip this around and solder them. Yeah, so I like watching people solder. I don't know if other people enjoy that, but I find it kind of relaxing to watch, which is why I am posting this video. And then hopefully we can take a look at the product and see how cool it is. I'll go ahead and show you a product listing on my computer at the end of the video too, so you can see the price. Or maybe I'll put it in before. That's probably a better idea. So just make sure these resistors are pressed close to the board. Sometimes when you flip it upside down like this, they can sort of fall apart. Yeah, like that one. Or fall away from the board, I guess is what I try to say. Okay. Cool. Got those on. Let's go ahead and trim the leads. If there's enough interest, I might do a follow-up video looking at the circuitry of this and trying to analyze it. I think that would be kind of interesting and probably a good experience for me. Okay, so got those in. Let's go ahead and look at the other side. Hopefully I don't mess up these traces by clamping on it. I think it's okay. All right, what's the next thing? Probably these little ceramic disc capacitors are pretty small, so that is 222. What is that? 222 with 2 zeros? Is that how that works? So 2.2 microfarads? Let's see. Let's take a look. You know, you'd think I know how to do that by now, or how to read these, but they never really taught us that. Sort of just glossed over it. Should probably mention that to them. Suggestion for the engineering program. Okay. 3.5. Yeah, it's probably yeah, it's hard to measure capacitances this low. Multimeters aren't very good at it in general, so I don't believe that. 2.2, let's see. This is 104. Put that in there. We have a 222 again. And another 104. One of the challenges of doing these videos, and I understand now when I hear other YouTubers complaining about it, is it's a little difficult to solder with a camera right over what you're trying to do. And especially when you're trying to remember to keep things in frame all the time and in focus. Okay. Just make sure all these leads are bent out so that I can solder them on without having to worry about them falling out. Okay. Okay. Those look like pretty good joints to me. So go ahead and trim them. See if we can do... Oh, I forgot to make sure that they were pressed against. Oh, they're probably fine. I don't want to fix it now. Okay. Go for trimming 2 legs at a time here. So yeah, I'm going for a math major, EE major, but I'm also trying to get a math minor. Right now I'm in the last math class I'll need to do that. And it's limits and infinite series, which is sort of a proofs class. It's really hard. It's one of those classes where I think the curve is probably going to take everyone up like 15% because otherwise everyone would fail it. So yeah, it's really rough. It's almost like more of a philosophy class than a math class. But I can get this out of here now, can't I? Okay, so let's put in, I don't know, these little transistors maybe? I wonder what these are. Can you see that? I think that says S9012. So that's going to go here. 9 bit so that I can get them in the holes. Like so. Good thing they have good pictures on this, otherwise I probably wouldn't be able to do it. Okay, then we have a 9012 again. Okay, it's going to go down there at the bottom right here. And this last one better be a 9018, and it is. Good. Little transistors of some sort, I'm sure. Probably forms some kind of oscillator circuit with those capacitors. All right. Get some good leaded solder on there. I think I need to get a little bit more on that middle joint. What do you guys think? Just a touch. There we go. Okay. Trim those. Okay. What do we need next? Maybe that's probably going to be the potentiometer. Sure, at this point I don't think it matters that much because I'm going to have to hold these anyway. So let's get that into position. There's the legs on this are a little bit weirdly shaped, as you can see there. So let's get those in. All right. I'm just going to have to hold this. You know, something I find kind of interesting is that there's not a whole lot of American electronics YouTubers. And I mean like North American, like everyone seems to have a British accent, or, you know, there's Dave at EEV blog with his Australian accent. Big Clive is Scottish. I don't know, I just think it's kind of interesting. Kind of where most of the electronics YouTubers are from. Just an observation. Of course, there's nothing wrong with that. Get this switch in. Oh, wait. Oh, yeah, I could do this capacitor, I guess, and the LED. All right, so positive is going to be on the top. Okay. It's a little bit tricky to hold this one. Okay. That looks good. Just trim those off. I'm just going to set this one down. Do it the lazy way. Solder one of the legs and make sure it's pressed down. Yeah, okay. Then we do the rest of them. Let's make sure that's in focus for you guys. I'm sorry. Okay. Switch is in place. Let's do the connector here. Actually, no, should do the LED first. The longer leg of the LED is the positive, or the anode. And it also should have like a little flat side, which is going to be hard to show on video. Yeah, I'm not going to be able to show it, but this side of the LED is like flat, so yeah. So that is shown on the diagram there, so we're just going to put that in as shown. And I lost it. Did I get that in the right way? I don't think I did. It's this way. Whoops, sorry. Okay, we're almost done here. Just have the buzzer and 5-volt connector to go. maybe the buzzer first, because I think it will be just a little bit easier to do. Polarity shouldn't matter on that kind of thing. Okay, there's high thermal mass on this. This pad is, so you can see this pad has this big ground plane here. It's not taking solder super well. If you've ever looked at these kinds of pads, here I'll focus in for you. Okay, so can you see how there are these pads here, and they're not totally connected to the plane around it? The reason they do that is because you still get pretty good electrical connection with those little connectors, but it's more thermally insulated, which makes it easier to solder to. Because if that pad was connected directly to that plane, it would just suck away all the heat, and it would be really difficult to solder to it. So that's why they do that. Because the resistance of that is still really low. It just makes it easier to solder to. That is something that I actually did learn in school. All right, and these are also really big connectors, so they're going to take a little bit of heat and just a moment to solder to. All right, that looks good. Do this one. Again, just give it a moment to warm up. Okay. So that's the circuit done. I'll have to get a 5-volt supply, and I'll be back to show you guys. Okay, looks like my camera is moving a little bit there. Okay, so I have the power supply hooked up. I'm actually recording this video after I went out for dinner, so just a little fun fact. Got my screwdriver stuff here. Okay, let's try it. I haven't tried it yet. Let's go ahead and plug this in to 4.5 volts. Let's go ahead and rip this sticker off first. Cool. We're going to have to power it on. Okay, that's a good sign. Oh, yeah. That seems to be working. What else can we test it with? Let's see, do I have anything? It's going to have to be probably a ferromagnetic material, or is it going to test all metal? Okay, why is it just on? Maybe we need to adjust the potentiometer here. Let's get the screwdriver in. I have no idea if I'm adjusting it the correct way. Well, it's turned on. Let's turn it off, and maybe touching the things might mess it up. Okay, we haven't gotten a tone out of it yet. Oh, okay. So it looks like maybe you're supposed to put this right on the edge there. Oh, yeah, look at that. Look at that. And it looks like this is not producing. Oh, it is polarized. Did I say that it wasn't? They definitely are. I don't know why I said that. All right, so I'm gonna have to go ahead and flip that around, and then it should buzz when metal objects are put near it. Wow, that's really cool. What else do I have around here? That works pretty well. That works really well. Wow, that's really cool. What if something like small like this? Okay, that's a little too small. What about a few of them? Oh yeah, two is enough. Wow, that's really cool. All right, I'm probably going to try to do another video soon that looks at how this works. I'll draw out the schematic for it. I'll take a look at the waveform of this on the oscilloscope maybe. Also interesting, if I touch the bottom of that right there, that transistor, it seems to turn on the LED. Or this transistor. Huh, interesting. So yeah, it's definitely some kind of capacitance thing between this coil and whatever object you have near it. All right, very cool. Thanks for watching. Link is in the description.